Theoretical recap. In Linux, every file and directory has two ownership attributes, a user owner and a group owner. These are distinct from permissions, which you have already practiced with chmod, but they work hand in hand. Permissions only mean something in relation to who owns the resource. Chown, change owner, allows you to modify the user owner of a file or directory, and optionally its group owner in a single command, chown user group file. chgrp, change group, is more focused. It changes only the group owner. Both commands require elevated privileges, sudo or root, to reassign ownership to another user. A critical mental model. Think of ownership as the identity layer and permissions as the access layer. You can give a file read/write permissions to its owner, but if the wrong user owns the file, those permissions protect the wrong person. This is a classic misconfiguration in security contexts. Common mistakes. Forgetting sudo when reassigning ownership to a different user. Confusing chown user file, changes user owner only, with chown user group file, changes both. Using chgrp when the user is not a member of the target group. Applying changes non-recursively on directories when recursive behavior is needed, rflag. Mini example, sudo chown www.data www/var/www/html/index.html assigns the file to the web server user and group, a typical DevSecOps configuration to prevent privilege escalation on web servers. Workshop brief. This workshop places you in the role of a junior Linux system administrator preparing a secure multi-user environment for a small DevSecOps team. The environment contains several directories and files representing different services, a web application directory, a shared scripts directory, a logs directory, and a configuration files directory. Your mission is to audit the current ownership state of these resources, identify misconfigurations that could represent security risks, and correct them by applying appropriate ownership assignments using chown and chgrp. You will begin by creating the directory and file structure yourself, simulating a realistic deployment scenario. Create the following structure under /ops/devsecops_lab/ a web app directory containing index.html and config.php, a script/directory containing deploy.sh and backup.sh, a log/directory containing access.log and error.log, and a secret/directory containing db_credentials.env. All files and directories should initially be created as your current user. Then create two additional local users, devuser and opsuser, and one group, DevSecOps, adding both users to that group. Once your environment is set up, apply the following ownership requirements. The web app/directory and all its contents must be owned by devuser with group DevSecOps. The script/directory and its contents must be owned by opsuser with group DevSecOps. The log/directory must be owned by root with group DevSecOps. The secret/directory and its contents must be owned by root with group root exclusively. Use both chown and chgrp commands during this exercise. Do not rely exclusively on one of them. Where applicable, apply changes recursively. After applying all ownership changes, verify your work using lslaw and stat on key files. Document each command you ran and its output. Then reflect on the following questions in a short written report, minimum 1 paragraph per question. Why is it dangerous to leave sensitive files like db_credentials.env accessible to a group other than root? What would happen if deploy.sh were owned by devuser instead of opsuser in a real production context? How does ownership interact with the permission bits you have already studied? When would you use chgrp instead of chown user group? Finally, introduce a deliberate misconfiguration. Change the owner of config.php to root while leaving group ownership as DevSecOps with permissions 640. Then simulate a diagnosis. Document what problem this would cause for devuser attempting to read or modify the file, and how you would fix it. This last step is meant to train your diagnostic and remediation reflexes, which are central to the cybersecurity and DevSecOps role. You are allowed to consult all previous course materials, permissions, chmod, file manipulation, navigation, and any relevant online documentation such as the Linux man pages, the Arch Linux wiki, or official Ubuntu documentation. You may work alone or seek help from peers, but your written report and command log must reflect your own understanding and reasoning. Submit your complete work, command history/log, verification screenshots or terminal output, and written report before the deadline.